Hello! In this video I want to talk a little bit about showing conditionals. Again, something we've talked about before, but there's a little bit here I want to make sure that we're clear about. So, if you want to show a conditional if box, then circle, well, you get box with assume CD, and then you want to get to circle. And then you can apply CD to circle, and that lets you box and cancel if box and circle. So we've known all that. We want to know that that's whenever you have a conditional in the show line, this is what you want to do. This is a familiar strategy. But there's a question here about, well, okay, how do you get circle? And there's a main way to do that, and that's by showing circle. So you would show circle and then make another assumption. You'd box and cancel, show circle, and then you immediately box and cancel the whole thing with CD. So let's take a look at some examples of this. Okay, so here we go with a theorem. We're going to do some examples of we're going to look at some examples of showing conditionals. So again, we're going to show the conclusion. Of course, we make an assumption. It'll be a conditional assumption. Now, we can think, without even thinking about what's going to happen in the derivation or sort of what we have or don't have, whether or not the derivation is stuck or not, think this is a good idea. So once you start this subderivation, we know what's going to happen when we complete it. We'll say 3CD, and that gives us the consequent of what we're looking for. And so this is never a bad idea to do. In this case, we need to do it, but it's never a bad idea. And now once we have this new show line, we can in fact make an assumption, and we can use this not Q to get not P. And that's the consequent of line 3, and then we'll apply CD. Okay, so that's fine. That's pretty familiar. But let's look at a few more examples of this strategy in action. So here we have a bigger sentence. So again, we're going to assume the antecedent and try to show the consequent, and we're going to make a conditional assumption. But now, there's more to do. We could say, let's show the consequent of this. We're still trying, if we look at line 3 is a conditional, and so it would be nice if we can box and how can we box and cancel line 3? Get its consequent if P then R. And so we can use this show command that will just stick in the consequent. And again, we'll make an assumption. And now once we get this P, we can start moving. Although we could even keep going further. We could say show cons again, because if P then R has a consequent, namely R. And now here we would want to make an assumption again, and this time it would be assume ID. And now there are no more shows to be done, and so now we can put together the lines that we have and see if we can box and cancel. And since we made an indirect assumption, one way we might finish is with a contradiction. So if we can say, well, 2 and 6 go together with modus ponens giving us Q. 4 and 9 together go together with modus ponens giving us R. And now we actually have a couple options here. We could say 10 direct derivation because R is what we're trying to show at line 7, or we could say 10, 8 indirect derivation because 8 and 10 contradict each other. In fact, we didn't need to do this as a subderivation in this case. We could have gotten to R without doing a subderivation, but this shows that it doesn't hurt. You can just keep showing consequent until you can't do that anymore. And then we say 7 CD. Then we say 5 CD because 5 is the consequent of line 3. And we say 3 CD because 3 is the consequent of line 1. And so this show cons thing here, how does that work? So if you're trying to show a conditional, as we are at this point, we think, well, if I type show cons, it's going to write a show line that is the consequent, right, of the conditional that we're trying to show. So that's how show cons works. So you can copy and paste this, or you can type it out using the keyboard shortcuts or this pop-up window. But you can also use this show cons command to make it just enter the consequent for you. Okay, let's look at one more of these. Okay, so we're still trying to show a conditional, so we'll say assume CD, and we'll go ahead and say show cons, and now, right, so now we're trying to show this is that. So what we're trying to show in line 3 is the consequent of line 1. Now line 3 is a conditional, so we'll say assume CD again. Now, at this point, if we look at lines 2 and 4, the derivation is stuck, and so we have to, in this case, do show cons. We want to box and cancel this. How do we do that? We get P. So if we get P, the derivation we can box and cancel that, and if we box and cancel this, we can box and cancel that. So P is going to help us is going to allow us to box and cancel line 3, and at the same time the derivation is stuck, so we have to do some sort of subderivation. At this point, the derivation is stuck, so we need to do another subderivation. So now we say show P, and now we need to make an assumption, so we say assume not, we'll assume not P for indirect derivation, and now we can use not P with line 2 and also with line 4, and we get a contradiction, which is what we should be expecting because we started here with an indirect assumption. So that gives us P, and now since P, what we just showed is the consequent of line 3, we can apply CD to line 5, which will box and cancel line 3, and now 3 is the consequent of line 1, so we can apply CD to line 3, which will box and cancel line 1. So what have we seen here? There's a show con shortcut command. It makes sense to apply it whenever we can, and you can just keep applying it until you can't apply it anymore. So in the very first derivation, if you remember, oh, it's gone, but that's okay. I'll bring it back quickly. We did this, and we said, okay, this is all we need to do. But so at this point, we didn't complete this show cons structure, because we could have said show cons again. We could have said, okay, I want to show not P. In this case, that's unnecessary. You can get to not P without doing this last subderivation, without doing this, right? The way we did it was we said 2, 4, MT, and that got us not P. So you don't have to do a subderivation of not P, but it doesn't hurt. And in some of these derivations, like number 4, we say show conclusion, assume CD, show the consequent because we're trying to show a conditional, assume CD, show the consequent again because we were still trying to show a conditional, and now we say assume indirect assumption. And this time, to get P, we have to do it to get the consequent here, we do have to get all the way down to P and then make this indirect assumption. So the key thing here is that you can keep doing show consequent. You don't just do it once, you can do it repeatedly. So the key thing here is, if you're trying to show a conditional, show the consequent. And that's not true for just the first show line. That's true for any time you're trying to show a conditional, whether or not that conditional is the conclusion of the argument or it's a subderivation. If you start a subderivation that has a conditional, then do another subderivation of its consequent, and keep on doing that until you're not trying to show a conditional anymore. You're trying to show something like P in that last derivation that we looked at. Doing this will never lead you astray. It might make the derivation a little bit longer than it needs to, but it's never going to lead you in the wrong direction, and sometimes you have to do it. So if you're ever trying to show a conditional, I would say make the conditional assumption, but then immediately at this point say show consequent as well, and set up yet another subderivation. In a lot of the derivations we've been doing in the past, we didn't need to do this. We don't need to do this in all of our derivations now, but you want to at least have it to be a habit. Look for the opportunity to do that next show consequent subderivation, and really I would say just do it, make it a habit of doing it. It makes derivations maybe 2 lines longer. That's fine. It's worth doing that to make sure that you don't miss a subderivation that you need to do.